Okay, paper 42 and October, November 2021. The question number 2 is state the relationship between the gravitational potential phi and the gravitational field strength small g. Look, in theory, we have done that the gravitational potential is equal to minus g into t. So we can write G is equal to minus phi divided by D. So from this equation, we can deduce the result. So gravitational field strength small g is the negative potential gradient of gravitational potential against distance graph. If the graph is plotted, suppose phi at the y-axis and the distance at the x-axis, then the negative gradient of the graph is equal to g, which is gravitational field strength. Next is the moon of the mass m and the radius r orbits a planet of mass 3m and the radius 2r. At a particular time, the distance between their centers is d, as shown. The point P is the point along the line between the center of the planet and the moon at a variable distance x from the center of the planet. Suppose the planet is Earth. The variation with x of the gravitational potential at a point P for points between the planet and the moon is shown. So this is gravitational potential against distance graph. And question is explain why phi is negative throughout the entire x to r to x t minus r. So 3 points. So first of all, we have to write that at infinity, gravitational potential phi is 0. Any planet. But all forces, mean all gravitational forces, are attractive in the universe. But one has to perform some work in bringing object from infinity to point in the field, thus phi appears negative inside the field. So this is the answer. 3 marks. Number 1, at infinity, gravitational potential is 0. In the universe, all forces are attractive. Number 2 marks. But one has to do some work. So this work done in bringing the object from infinity to field point appears negative. So the phi is negative because the phi is equal to work done per unit mass. Right here, the negative sign. One of the feature is that the phi is negative throughout. Describe 2 other features. So look at the graph. This is negative, yes. And number 2 feature is the gravitational potential at the planet's surface and the gravitational potential at the moon's surface has different value. This is another feature. So gravitational potential phi has different values at the surface of planet and the surface of moon. Mean potential is not equal. This is one of the features. And the next is look at the gradient. So if we go 1, 2, 3, 4, 5, and 6 boxes here, 6 boxes vertically, then 1, 2, 3 boxes. So 6 divided by 3, the gradient is 2. And similarly here, if we move 6 boxes vertically, suppose we start from this point, 1, 2, 3, 4, 5, and 6. So here is just 1. So 6 divided by 1, answer is 6. It means the gradient of the graph at d minus r is greater than the gradient at 2r. So the gradient graph at the surface of moon is greater than that at the surface of planet. So this is another question. Now the question is, on the figure 2.3, sketch the variation with x of the gravitational field strength G at the point between 2r and xd minus r. Okay, so this is G and D graph. So we have to start it from the surface of the planet. So planet has the largest, the greater gravitational field strength than the moon. So suppose we start it from this point. So one side, this is positive, and the other side, this is negative. So suppose at the moon, this is the value. And somewhere close to the surface of the moon, the resultant G will be 0. And here is the point where it is 0. So suppose we take this point. We have to sketch this. So this gravitational field strength is decreasing. The resultant G becomes 0 at this point, and then it increases. This is no need to draw the G graph inside the planet. So this is the graph.